Like I said, we're going to cover some of just some troubleshooting issues we'll have with the ISG and the WPM, and just the sort of the system in general. Hopefully, we can bestow a bit of information in this one that you can get some techniques to combat some issues. Okay, so first of all, okay, I just punched out a little list of what I'm seeing as the most common problems. Okay, air in the system, high pressure faults. Okay, that is the most common problem we see. Okay, so, for every 10 problems, 8 issues would be down to air in the system. And it comes down to a lot of the time with installation, there's a lot more componentry potentially in a lot of our systems than a potentially another off-the-shelf monoblock heat pump where it's just a on-off, connections in and out of the back of the heat pump. We do use buffer tanks, we do multiple heating circuits, we do domestic hot water integration, we do pool integration, we do all these additions and add-ons. So getting air out of the system on installation is imperative, and putting air bleeders in the right place are imperative. And knowing how to charge and run your pumps on a commissioning, when you're commissioning, can be a very, very valuable and time-saving thing to do. So that's something we're going to go look into throughout this presentation. Incorrect bus wiring, color coding, number 3. Obviously, quite often, people are just putting things in the wrong spot. It's not hard. It's not hard, especially when you're extending wires and you're using like a multi-core, like a bus, like a Cat 6 or something like that, and you've got multiple pairs in the one cable. Quite often people can just pick the wrong pair and wire it incorrectly. And how to find these things and how to recognize that it's a problem, that's what I want to talk about in this module. FET, incorrect allocation. FETs. FETs are our room stats. All of our FETs, actually, I might just push on a little bit as I'm talking. All of our FETs wire into the green bus terminals. For those that have been in others, which is pretty much everyone, the green bus terminals, remember, are your accessories bus connection. So the green will contain your stats and your ISG. Now, the 2 green bus terminals, X1.2 and X1.18, are the same. It does not matter which end you connect to or spreading them out between them. However, if you have a system where you have 3 or 4 or 5 FETs, they can all wire into the one position. They can just parallel in to the one set of bus terminals, the green ones. So what then has to happen is you need to allocate your FET for the particular heating circuit, because you'll turn them all on and everything will power up. The FETs will all light up. The first screen of the FET will say, ask you, select your language and so on. And then it's going to ask you what heating circuit it needs to get allocated to. So what I'd normally do is, start from one and just one at a time, allocate the heating circuit. If you mess up, which is very possible, you accidentally allocate the FET to heating circuit 3 instead of heating circuit 2, you can either go into reset on the WPM and you can reset all the heating circuits, or, reset all the FETs, which then you have to just load them up again, or you can just pop them off the wall and swap them over. So I've had people do that. They've set up all their heating circuits. They've got 5 heating circuits. They've figured out they've got heating circuit 2 and 3, the controllers, the room stats the wrong way around. And I've said, instead of setting up everything again, just pop them off the wall, take the plug out and just swap them. That is a very, very easy thing to do. Okay. So sort of back up to the top. Now, looking at a single heat pump system and potential issues and troubleshooting a single heat pump system. Obviously, you've got the heat pump, you've got the fill, the fill set, expansion tank, and so on. Just be aware. I have said it a couple of times on others, but I'll say it again. This is being shown as indicative. So the expansion tank and the gauge and the fill set as shown is just indicative. just showing where it goes into a system, just so people know where to put. That is a field supplied item, like the pumps. Oh, sorry, like the pipe. Okay. So you've got one heat pump. You've got the buffer charging pump. In this case, it's an SBS tank for those that have been with us for the whole thing, where we're doing a zoned application. But there is one buffer pump. You know, it's hard to get that wrong. It just goes into buffer pump 1 position on the WPM. So I'm going to look at the WPM here. It's actually cut off the bottom here. I'm not sure why, but if you're looking at in the WPM, which is the heat pump manager, X2.6 is heat pump 1 and X2.7 is heat pump 2. Okay. Now, if we're doing a multiple heat pump system, this one being 2 heat pumps up to 6, we're going to need also a WPE, which is the expansion module, to get us another 4 spots for heat pump buffer charging pumps, because there's only 2 in the WPM. Now, as you are powering up the WPLs, the heat pumps, as you power them up, they are assigning themselves a heat pump number. Okay, so you turn on the first heat pump in the sequence as you're powering them up, it will allocate that first heat pump as heat pump 1. You turn on heat pump 2 and so on and so on. It will allocate those units in order as you're turning them on, because they're all effectively on the same bus network. It's just a network. You have to address the individual items so they know what they are. Now, the reason this is important is because if you've got a 2 heat pump set like this, where you've got 2 heat pumps, 2 buffer charging pumps, all manifolding together, going into the 1 buffer tank. And you've got the WPM, where 2.6 is heat pump buffer charging pump 1 and 2.7 is buffer charging pump 2. If you put those pumps the wrong way around, then in fact, whatever's allocated as heat pump 1 might start buffer charging pump 2 and vice versa. So I have had this problem multiple times, where the heat pumps are allocated in a certain manner and the buffer charging pumps are wired in a different manner. So once the complexity of these jobs obviously can be, exponential as far as keep putting more heat pumps on them and more heating circuits. So what we need to show you and what we're about to go into is, okay, how do I figure this out? How do I know which heat pump's which? And how do I figure out which heat pump has been allocated as which, and which buffer charging pump is going to start? Okay, so we'll go into that a little bit further in a moment. I might just keep running through the common problems. Sensor wide in the wrong location. Yep, that's very common. EVU, I'll come back to a couple of these. We'll do a bit more detail. No voltage on the control circuit, mixer wire backward, elements not hooked up, flow rate low, ISG connection, pumps, sensors incorrectly allocated. So error in the system I've made mention of. I'll just finish that though. Be aware, the heat pump themselves all have an air bleeder point. So it's a very, very effective air bleeder point because it bleeds the air from the top of the heat exchanger inside the heat pump. So in the case of a WPL 25, our most commonly sold heat pump, if you go to the back of the heat pump near where the pipes are, there's a little white knob which you undo and it is an air bleed point. So what I always suggest is on commissioning, get your water flowing into the system and be bleeding it out of the back of the heat pump. Very effective air bleeder position. Air bleeders in the top of buffer tanks, very common obviously. Some people don't put them there. We always recommend them because the buffer tank is a very, very effective spot, more effective than having air bleeders in the pipe work, because once the velocity changes with the water coming in, the air will rise to the top. Because you imagine you've got high velocity water coming down a pipe, punching into the buffer tank, and all of a sudden you've got a very low velocity situation in the buffer tank, then the air will all rise to the top. So that is more effective than air bleeders, say in your pipe work where you've got fast velocity running through. Air bleed points, and obviously air bleed points are any of your high points of your system. Okay, but and in the trend module, and then in the HSBC, for those who've been in other presentations, which I think is everyone, you'll find there is actually an air bleeder point at the top in the HSBC and in the trend module. On the front, on what's called the MFG, which is the hydraulic device, which is the big black module. I might just bring up a slide and actually show you that in a minute though. Okay, so let's look at, okay, incorrect bus wiring color coding. Okay, that is more the point I'm just referring to, is that you've got the bus terminals, and instead of putting the heat pumps on the red, they put the heat pumps on the green, or the accessories on the red, okay? Now, of course, it is very possible as well to get the coding within the wiring, as in you get the L and the H swapped around or something like that. What we want to do to be able to figure this out, I'm just going to go to another screen, okay? Just going to bring up the WPL Simulator, okay? So the WPL Navigator is a excellent tool, which is in the toolbox, which I've been pointing people to throughout all my presentations. Okay. And it's going to show you a simulation, like I said, of the WPM, okay? So in the WPM, okay, a couple of things. Let's, what I was referring to, let me just go back to what I was referring to. I was referring to air in the system. So air in the system, obviously the most common problem. We'll probably spend the most time on that, and we'll show you some excellent ways to help you establish if you've got air in the system and to help navigate through it. Okay, firstly, this is what we're looking at in the heat pump manager. Okay, let's pop into the menu. Push it for 3 seconds. Okay, just checking everyone is looking at the WPM Navigator. Can I get a thumbs up from someone? Yeah, that shows verifying too. Just checking I'm on the right screen. Thank you. Okay, firstly, let's go into diagnosis. Okay, because remember what we're trying to do here is commission our system and try and get air out of the system. Okay, so one of the first things I do on any commissioning, and I'll take this more when we're going into the commissioning modules, but what we're doing here is obviously fault finding and so on. And one of the main faults we have is trying to get the thing running. Okay, so relay test. So if we are on the front menu, we go to diagnosis, and then we go into that, and we will go down the bottom and we will go to relay test. Okay, relay test system, WPM. We can go to every output on the WPM, and we can turn on that pump. Now, in the case of the heating circuits are 2.3, 2.4, 2.5. We can pop those heating circuit pumps on. So remembering, this is before you've even tried to start the heat pump at all, generally speaking. You want to go and relay test all your pumps and make sure they work, okay? So you can turn your heating circuit pumps on. You can turn your buffer charging pump on, being 2.6. That's buffer charging pump 1. Let's turn on that buffer charging pump. Let's see if we get any air coming back to the buffer tank. Let's see if we can hear that pump make any noise. Let's see if the lights come on the pump. Very important, okay? 2.7 being heat pump number 2. Now, another one of the points I made that people get stuck on is they don't know if the right circ pump is going to the right heat pump. So you can turn on your circ pumps individually, and you can check whether you have the right flow going to the right heat pump. You know what's wired in the right spot. You may not be able to see the wiring. The wiring's all extended, going in and out of junction boxes. You're not sure where it's going. You can physically turn on pump 1, buffer charging pump 1, which is 2.6, and you can say, oh, okay, great. That is the one that I am allocating to be buffer charging pump number 1. Same with pump number 2. I have had countless commissionings where someone goes, the unit's not going, and I'm going, have you got flow? I'm not sure if I've got flow. Let's get the pumps going. Let's just get the pumps going and see where we're at. Okay, all right, 2.8 being your domestic hot water pump. Also, very important, we can turn off and on the mixer motors. Now, if I just jump back onto my other screen, I'll just jump back into my presentation. Mixer motors number 7. I'll just bring this up. Hold tight, everyone. Mixer motors. So on the WPM with the wiring, looking at who's in here, most people are sort of up to speed with what I'm talking about. I'm not jumping around too much. Okay, but we've got our buffer charging pumps in 1 and 2. We've got our heating circuit pumps 1, 2, and 3. Heating circuit mixer 2.14 is the mixer motor that's attached to heating circuit number 2. And 2.15 is the heating circuit, is the mixer motor attached to 2.5. They are a drive open, drive closed motor. Okay, so making a big point of this, because this has actually been another big problem that I'm seeing, is people are wiring in those mixer motors back to front, and when the unit is saying to open, the mixer motor is actually closing, and vice versa. So be aware that we need to have them operating the right way, and the right way to do it is to be able to go into the relay test and actually operate the mixer motors. When the unit is turned off, so if the unit is in standby, the mixer motor should close. So the mixer motor is sitting there closed, and then the unit is put into operation mode, and it should slowly start opening to allow heat going to the heating circuit. So like I was saying, you want to be doing this all before you even try and start the heat pump. The last thing we want to do is be trying to start the heat pump, and then you've got absolutely no flow. The heat pump just faults out immediately. Sorry, I'll just jump back onto that. The heat pump faults out immediately, and you've got no heat. Okay, so back up to my main faults. Okay, air and system. We've covered that. If you've got no flow, you've got the wrong pump allocated, you don't have correct air bleeder points, you are going to get no flow. The problem with our pumps we use, we use Wpl, variable speed pumps, excellent pumps. When the pump's running, or when the pump's pumping beautifully, no air, or when the pump's not pumping at all, potentially no water, they sound almost the same. The only time you actually hear the pump is if there is air in it, pulsing air and so on. So people do struggle with knowing whether the pump is going and pumping. So like I said, one of the things I'll always be recommending and pointing people to first, relay test, and you can actually turn the pumps on, see what's going on. Okay. Incorrect bus wiring, we've covered. Incorrect bus wiring, color coding, we have covered. FET covered, sensor wired into the wrong location. Okay. Okay, I mean, pretty basic one. Sensors. All up here is all sensors, and all up the bottom is our 240 volt output, as we've discussed. Okay, if you've got your sensor wired into the wrong location, it will not bring up the corresponding menu for what that sensor is supposed to be controlling. Example, if I want to put a second heating circuit onto a system, I need to put a sensor in, okay? You can't activate a second heating circuit without a sensor. So pop a sensor into heating circuit number 2, reset the power, okay? Big one. You can put the sensor in, you can do whatever you want, unless you reset the power, which allows the system to reconfigure itself knowing a sensor's there, it will not find it. As soon as you put the sensor and reset the power, then you will have the settings menu giving you heating circuit number 2, okay? That way you've wired it into the right spot. So A, be armed with the right information. We can just send all this stuff. This is why I just keep this very handy to me on my laptop. I just bring this up at a moment's notice so I know where everything's going. Anyone that's doing numbers of these, should too. This should be part of the quick reference guide that you can just bring up the WPM wiring. Note, the WPM system, which is the new gen controller, is being rolled out pretty well across everything. So it's in the new trend modules. It's in the new HSBCs. Anything that's been delivered on site for the last 6 months, realistically, unless it's come from somewhere different, as in different logistics company or something, has got the new WPM in. So this suits 99% of what's being installed. The only exceptions being maybe the commercial units with a different controller, which we'll go through in another session. Okay, and being commercial geothermal units specifically have a different controller. Okay, now we also talk sensors. So sensors obviously can be widened to the wrong spot, and sensors can be located in the wrong spot. Now, I've showed this screen a couple of times. I hope if there's anyone that hasn't picked it up already, I'll run through it a bit quicker. But obviously, we're showing the location of the sensors on our schematics, and we're showing the wiring position. So we know that 1.3, that's our ambient air sensor, and that is going into 1.3. That's our outdoor temp sensor. We've tried to make this simple. A couple of people have been in the presentations and didn't realise this was the case with our numbering of the wiring positions, and now they know that. They say, "Wow, that's got to make their life easier, significantly easier." So, know where you're wiring it to, have the information, know where the other end's got to go, the sensor, and know how to configure the sensor by turning the system off and on to repower it so it reconfigures, and then it will populate in the menu. If it's not in the menu, for example, you're doing a domestic hot water system, you put the sensor in, you turn it on, it's not in the menu as domestic hot water settings, then you may have the sensor in the wrong spot. Be looking at that. Okay, EVU, not so much now. When people were doing their first installations, this caught a lot of people out. What the EVU is. EVU, I'm sorry about these slides, cut the bottom off for some reason. But anyway, the full picture shows just this right here, X2.2, L, the apostrophe, that is called the EVU input. Okay. What the EVU input is it's a 240 volt input that can be controlled by the utilities companies. So in Europe, these are a must-have that you may have your utility, your electrical provider. They have a relay, be it in your board or somewhere, where they can turn off and on loads of systems to load balance town or an area or something like that. And they may guarantee you 15 hours of your heating system, domestic hot water system can be on a day, and they'll give you between this and this hour. That's what the EVU is for. So the EVU, if you need to link the EVU from the L over to there, from the live to there, if you just want it to be on, or you can put that through a relay if you want to turn the whole system off and on, if you want that function. But if you take the power out of there, the whole thing it'll stop the heat pump and everything, but on the WP, on your controller, it'll just say power off. So a few people, when they, I get people to look at the front controller first and foremost when they're trying to commission units, and I say, what does it say? Does it say power off? They say, yeah. How do I turn it on? I say, yeah, you need an EVU. Okay. That's what the EVU is. Okay. Like I said, it caught a few people out to start with, but we're sales guys need to know that. Everyone needs to know that. Everyone in the Steeple team needs to know that, and installers, of course, you'll get across it. No voltage on the control circuit. Okay. In the heat pump, our heat pumps have multiple control voltage inputs. All of them do, okay? We've got the main control voltage, which drives the heat pump and is where the line share of the current, of where the power usage is used. They will be the WP terminals, WP meaning heat pump in German, okay? Also, we have a 240 volt input, which is the control circuit. Now, this is the way that they're done in Europe. Okay, people ask me quite often, why do you do that? Why can't we just have one circuit and internally it's linked? I said, it's just not the way it is. It just isn't the way that they're done. I'm not exactly sure. There might be European wiring regulations. I'm not sure, but be aware that we've got terminals, main terminal input for the main power, and we've got control power input. So if that control power input is not there, then the printed circuit board is not powered up on the heat pump, which is the IWS, and then the heat pump will not, the WPM, heat pump manager, will not find the heat pump. Okay. Now on that, let's just pop back onto I'll just pop back onto our WPM navigator. So what I've been saying throughout all these presentations is that we run on a bus network. So we run on a communication network. So The very first thing, in fact, and we'll cover this more in all the commissioning, but the very first thing I get somebody to do, once again, this is still before anyone's attempted to turn anything on or power it up, is try and see what is being identified on the network, okay? So in the case of a 3 heat pump system or something like I was showing you guys before, we go into diagnosis, okay, menu, diagnosis, and then we go down to system. And in system, you're going to find bus subscribers. Bus subscribers is what it says. It is what is subscribing to the bus network. So you click in the bus subscribers or go on to bus subscribers on your controller, and that will give you a list of all of the items that have been found and are communicating on that communication network, the bus network. The WPM will be listed there. The FES, which is the controller for the WPM, will be listed there. Any heat pumps as they've been turned on, they'll be listed there, and they'll be listed there as heat pump 1, heat pump 2, heat pump 3. Okay, and it'll show you their software version. It'll show you, in order of the heat pumps. It will show you if you've got a WPE, which is the expansion module for the control system, which allows you to do your pool heating and also. So it will all be shown in the bus subscribers. So no, back to troubleshooting. Item 1, get air out of the system. Item 2, make sure the system's all communicating with each other. We've got a lot of componentry here. Let's check that it's all communicating. So I did a quick commissioning yesterday between, Monday between some sessions. And I said, jump on the bus subscriber, what's there? The heat pump's not there. I said, okay, have you got your power on for the heat pump? You ever got the power on for the heat pump? Have you got your wiring into the power and the control circuit on the heat pump? I'm not sure. Got them to get me a photo. No, they hadn't. Get that sorted out. Okay, pretty easy. So the bus subscriber will show you what's there and the software. There are times where we can do updates and so on things, particularly with our new gen heat pump management system. And if we can do an update, we've got different software versions and we're able to see actually what version is actually on the system at that point. Okay, heat pump type. The WPM, being the heat pump manager, can obviously control a significant number of heat pumps. So there's not a heat pump manager per, specifically designed for that heat pump. No, the WPM manager, can go across multiple types of heat pumps. So when they configure, when they're powered up, in fact, it will show you what heat pump type the unit thinks it has. Okay. Now there are some deeper levels of configuration and so on, as far as if the configuration isn't there, there is ways we can do reconfigurations. I probably won't go too deep into that now. That's something that we just talk someone through, as far as, at the time when that was happening. Okay, so bus subscriber, very important. So far we've covered relay testing in the controller, and this is all in the diagnosis menu, okay? We'll just pop back to the other one. Sorry, guys. Got it. Okay. Okay. So mixer wire backward. We'll sort of check that. I haven't got here, but pumps and we did touch on pumps and sensors incorrectly allocated. Okay. So let me just go back into that, and I'll just show you some interesting thing when it comes to the relay test once again. Okay, so I don't know if you saw in relay test, we can do a relay test on the heat pumps and we can do a relay test on the system. So the system being every single thing outside of the heat pumps, which that WPM is controlling. So if we start heat pump 1, being this guy right I'm looking at, I'm circling the front on the front, we obviously want 2.6 to start with that heat pump. So how do we know which heat pump has been allocated to which? That can be a problem. The easiest way to do it is you go into a relay test and you go relay, test, heat pump, and you can turn on the condenser fans one at a time and all the heat pumps. Okay. So, you know, I had a case where we had 4 heat pumps. The sparkies wired all up and they just powered everything up together. They weren't doing the commissioning. So then by the time the contractor got on site to commission the job, they found that they didn't know which heat pump was which. There was no idea. So the allocation was all over the place. This heat pump was starting up when they thought was the wrong one. So what we did, turned all the condenser fans on one at a time, figured out which heat pump was which, made the decision, do we need to reallocate the heat pumps or do we just swap the wires around on the pumps? And the choice was made in that case to reallocate the heat pumps. So that's what we did. We then powered them all back down, turned the first one, did a reinitialization, then made it heat pump 1. Turned the second one on, did the same. So it's very important, obviously, to get this right. Now, if you are in the type of business that you are doing 2 or 3 or 4 or 5 or 6 heat pumps, you know, you're obviously doing very complex jobs and very, you know, quite large, you know, potentially expensive jobs. The time just needs to be allocated on these jobs for this type of thing. It's not a matter of just hooking them all in, turning them all on, and they all just heat the buffer tank to, you know, 50 degrees as a set point. You know, we're running these, we're speed controlling all the heat pumps. We're turning the pumps, the circ pumps off and on accordingly to match the heat pump that is running, and away we go. Okay. Okay, so what else we got here? Elements. Okay. So probably use this slide. Okay. The heat pump, the WPL 25, has element set built into it. Now, if we're using a hydraulic module or a HSBC, those 2 components also have element sets built into them. If you're doing domestic hot water and we're heating a tank, we need to get that tank effectively to 60 degrees to sanitize. It's a pasteurization. Now, the heat pump can do a WPL 25 can do a 65 degree flow. A WPL 17 can do a 60 degree flow. And generally speaking, we're using a coil tank. This is an SBS tank, but generally speaking, we're using a coil tank where we're putting the water, hydronic water, through the coil to heat the water around it, which is the potable water. So if we're pumping 65 degree flow through the coil, depending on the you know, there's factors, the temperature of the day, the size of the tank, the size of the coil, all sorts of things. There's a good chance we cannot effectively hit 60 degrees in the tank of potable water before the heat pump hits its high pressure limiter. It's almost you know, it's very, very likely that you won't. However, the WPL 25 can commonly heat a hot water SBB tank, coil tank to 55 degrees, and then it will stop on its high pressure switch. So what we then do, we incorporate the elements as part of our system. In the case of the 25, they can either be in the unit or in a module. But in this schematic here, we would hook up the elements in the back of the heat pump, and the heat pump manager would say, all right, the heat pump can do up to 55. The elements can make up another 5 degrees to get it up to our set point of 60. And there we go. We can sanitize the tank. Now, we don't have to do that every cycle. We can choose to run the heat pump at 55 degrees, the tank at 55 degrees, you know, as a rule. And then once a week, we can sanitize the tank with the elements to 60 degrees or 62 degrees or whatever we choose. Okay. But if those elements are not hooked up and someone is trying to do a hot water cycle and the heat pump hits its high pressure limiter and the unit tries to bring on the elements to heat the tank up to the set point of 60 degrees and the elements aren't there, then the system will just get stuck in a nowhere mode until someone comes and does something, because there are no elements. It's waiting for the temp to come up to its set point before it stops the domestic hot water cycle. That's common. When I say common, you know, I see that, you know, maybe once a month or something like that, that the elements aren't being hooked up yet, or getting hooked up later, or they weren't even factored, and the hot water is not. Now we can change some set points and bits and pieces to solve the immediate problem, but ultimately the tank does need to pasteurize. Now, if the tank needs to pasteurize and it needs its elements, they need to be hooked up. So any case involving domestic hot water, elements need to be factored in. Okay. Our new WPL range coming out, which Tom gave a sneak preview of on Monday, I believe. Our new Gen WPLs have a new refrigerant 454C, and we're talking, similar construction, similar engineering, but flow temps up to 75 degrees flow temp. So all of a sudden now we're really taking the element factor out. These units, are available. A models being available as of sort of the start of next year, and we assume others will follow. Okay, what else we got here? Low flow rate. Okay, either air once again, or someone's trying to use a pump, supplied by a third party, or they had a pump already in the system and they just want to think, I'll use that. It does baffle me why people sometimes try and save $100 on a $50,000 system and try and save $100 by putting a cheap pump in, but they do it. So they put an old 3-speeder pump in thinking it's going to be right. Sometimes it ain't. So, we do obviously supply a full range of pumps. They're pumps that have been engineered with our units. They're a good pump. They're a Wpl pump. We can either upsize the pump, which is one of the benefits of having external pumps, the heat pump, circ pumps, or, we can look at the size of the piping installation and say, all right, well, what's going on here? I'm sure most people have had some form of experience where the piping is undersized. We've actually taken on jobs where we've been brought in instead of another heat pump, and it's already been roughed in. And they say, the flow and return's all been running 25 mil. And we say, well, it's too small, but we can put a bigger pump on to compensate. The beautiful thing is, we've got a flow meter in our heat pumps. We've got a flow meter in our trend module and HSPC. So we can actually have a look at the flow rate, and we can adjust accordingly. Okay. ISG connection. Okay. We just covered this fairly comprehensively in the last segment, but ISG connection, that's a common problem. ISG setups. Without going over everything I just said in my last session, things you can do with ISG. A, have a look at the LEDs on the ISG. That gives give away what's going on. B, you can, if you're having problems setting up ISGs on site, set them up before. Okay. So commonly people are like, I can't get it going, I can't get onto the internet, yada, yada, yada. They're not home. I can't get on their Wi-Fi. Oh, all of a sudden you can't set up the ISG. But you could have set up that ISG back in the workshop, just plug it into your modem and get the detail in there and set the thing up. That way, when you plug it in on site, it just loads up, boots up and goes. It just starts, you don't have to do anything else on site. Just boot the thing up, check the LEDs, and away it goes. And pumps, sensors incorrectly allocated. I think we've sort of covered that. One thing I will show you, I keep glossing past the slide. This is actually, a picture of the WPM. This is the WPM without the plastic cover on the inside. This is what you're looking at. So all of these relays correspond, as it's showing, to the different, outputs. Now, what for those who are techie, what you'll notice is we pick up the active for the relays from this L2. So when we're installing, or when we need to wire up, we need to bridge to the EVU, and we need to bridge to the relay active. Okay, so we need active on both of those, not an active and neutral over to them, just an active bridge from there to there to there. Okay, that powers up the 240 volts for the relay, for the relays, and it also gives you your EVU signal. Why do we have a relay active, you may say? That is because you may have a massive system with huge pumps that you're not going to wire straight into our WPM, and you may want 24 volt switching. So you might put 24 volts on that there, and then all your relays are switching 24 volts, and then you can then on switch bigger contactors from there. Okay, one important thing about this. Each relay has got an LED light, okay? So for example, 2.6, if your buffer charging pump 1 was in there and someone says pump doesn't work, you can turn on the relay test, you can turn on X2.6, buffer charging pump 1, the corresponding relay should light up and you should have your voltage coming out of there and your pump should work, okay? Now, also, when the system's just in its normal running mode, your relay lights will pop up for whatever's operational at the time. So you just turn up on site to do a check. You can pop the front off the WPM and you can have a look what relay lights are on. You know, that gives you your indication about what should be running at any one time, okay? And you can check that things are coming off and on. Now, over to the right here, next to that plug there is the front screen. So you can actually take that off. The system actually runs without its front screen. So if you're there doing, you know, you're there doing stuff and you're playing with it and you're wiring it, you can't hang your front screen anyway. You can just unplug it, take it off. The system will just keep going. All the information is saved, and you know the unit will operate. Okay. That slot there is the update chip slot. So there is updates as they become available. We can update systems. Now, at the moment, any updates I've ever seen are just glitch fixes. There's no more functions, call it. But the updater will give you an option of updating the WPM, the WPE, which is the extension module, the FESs. So you can update the controller, being the heat pump manager, and you can update the wall controllers, and you can update the expansion module. There's updates available. Don't just go willy-nilly, just running around all your jobs and updating everything. If there's nothing wrong, don't worry about it. Just leave it, okay? Updates are there to fix bug glitches with certain functions, and that may not affect your job. But you know, there's been, you know, numbers and numbers of jobs where an update has fixed any niggling issues, and we've done them. Updates, just a micro SD, so we can just send the files just on an email, and you can just upload them into a micro SD. There's some instructions to do that, which we can provide. And you can just go, and then there's just a sequence to do an update. Okay, there's the pump. Okay, there's the pump motor. Sorry, that's the pump. That's the mixer motor. So what I was saying is, see that it's got a 0. If you can see that clearly, that at the moment is pointing to 0. You can little toggle here. You can turn it to manual, and you can manually operate the mixer motor if you so wish. Quite often, I've had, as I was saying, people wire them back to front and on's off, off's on. If the unit's sitting there in standby mode, the mixer should just go to 0, okay? If it's sitting on 10 in standby mode, you've got your mixer wired back to front, okay? Now, I've also seen people wire this mixer motor to like heating circuit 3 and wire the pump to heating circuit 2. Of course, that's going to make a problem. You just got to be across that type of thing, and that's why the relay test is important. Let's relay test heating circuit pump number 2. This pump should come on. Green light around the dial there should bring the pump on. Then let's turn on mixer motor number 2. Let's make it open. The corresponding one should do it. These are all the things, the troubleshooting things. You know, I've been back to site on jobs numbers of times and fixed a lot of these little items. You know, they're easy to do, and it's more comes through just understanding and knowing an easy way to figure out when you've got a problem. Okay. Also note, these gauges here showing temperature, it's a valve. I've had people say the nothing, heating circuit 2 don't work, pump stuffed. Can I get a new pump? And I'm like, you know how many pumps I've had fail? You know, in the best part of 2 years with Steve, I've seen, I couldn't even count them on one hand. We've got hundreds, if not into the thousands of pumps out in the marketplace. I can recall 2 pumps that have failed. So I'm going to call people out. You know, people say the pumps fail. I'm going to say, look, let's just go with the law of averages here. That's unlikely. That's unlikely. Check your valves are open. They're in the open position now. With you can see the cutouts on the sides. Cutouts face the way it is. They're open. Turn them 90 degrees right. They're closed. Okay. Obviously, your pump settings. I've gone into that with one of the pump. But at the moment, I went to a job. We had a job. Not heating the house properly. Then get there and find out the heating circuit pump's just sitting on one. You're not going to get the right capacity and flow through the house. So, pumps need to be set up. We'll go through that more in the commissioning. Bus subscribers, we talked about bus subscribers. ISG, we talk about ISG, what to look at. LEDs, I talked about this in the last session, but if you've got a power LED on and you've got green LEDs over on X1 and X2, you should be in business. If you've got any red lights on that LED, on that ISG, then you've got a problem of sorts. Okay. Now, just something to add confusion to the situation. Bus subscribers. When we're talking bus subscribers, which is finding everything on the bus network, remembering the ISG is on the bus network, the ISG doesn't appear in the bus subscribers. The only way you know if your ISG is working is it's got its LEDs. I'd love them to change that. That way it's consistent. But because the ISG, I think, has got its own communication indicators, it does not appear in the bus subscribers menu. Okay, and and I've shown here, this shows you lights on the ISG. This can all be sent to everyone. Anyone that was in the ISG one will if it's in the wrong bus, if it's in the red instead of the green bus, it'll all hook up, but it won't work. And if you've got your cables the wrong way around. Now, this wiring combination, white being H, brown L, black be your minus or your earth. If your H and your L are around the wrong way, in white around the wrong way on the ISG, it will corrupt the data network and you will have just frozen screens everywhere. Okay? So quite often someone says to me, okay, I've just got a Steve Eltron logo on the screen, nothing else. It's been sitting here for half an hour. I've been watching it. Nothing else coming up. I'll say to them, unplug your bus subscribers. Sorry, your bus plugs. They're just plugs, remember? I say, start from, and they say, oh, no, it's still there. I'll say, keep unplugging. Just unplug. Start unplugging, your communication plugs. And let's see when the screen comes back on. And invariably, they unplug the ISG. The whole thing springs back into life. And I just say, look, let's just get back to that later. Let's get this thing going in commission, and then we'll figure out what you've done wrong. And most of the time, they've got the L and the H around the wrong way. Not hard to do. Look, it's so easy to do. So easy to do. You're in there wiring. You could be in a cramped position or something like that, and you're just trying to get all your wiring in there. Might be in there correctly, might be in the wrong way. Something along those lines. Okay, we've looked at that. I've looked at that. Okay, let's just cover this. Sensors. What's the time? 4:05. I think I've probably got to stop in a sec. Sensors. We've got new sensors, the black sensors with the WPM system. The old WPM 3s, grey sensors, not compatible, okay? If you have an installation and you go to fire it up and all of a sudden your domestic hot water tank says it's reading 350 degrees, you've almost certainly got the wrong sensor in there, okay? So you need to have black sensors on the WPM systems. Unfortunately, this is a legacy problem where we've made the decision to change sensors without, we're trying to improve everything as we're going. We're going for the long haul. Our WPM systems are updatable. We should be seeing them stuck around for a long time. Some people have got some old sensors in their vans running around. Oh, you need a new sensor. Let's chuck a new one in. What's going on? The sensors aren't compatible. The outdoor air sensors, exactly the same. The outdoor air sensors are not compatible. WPM systems, that's type, the trend module is that. Notification lists, I've sort of been showing the notification lists. I think everyone here has been across that. Troubleshooting, just back to troubleshooting. Okay, you look at, I'm just showing just an example. This is a real world example of a unit that actually we'll talk about this one in the heat curve one as well. It's the Savo, where I took a system off fixed value operation and I put it on heat curve operation. And it was incredible, the actual improvement in this system and the running costs, you look at the average temperature the thing's pumping out in this versus the average temperature pumping out in the previous configuration, and we're not only heating the house better, but we're 30% lower running costs. It's staggering. And the best thing is we can measure all this stuff. Okay, I might just stop that share. What's the time? I've got a couple of questions. Okay, all right. I might just start that video. All right, hi again, everyone. 8 of us. I'll just unmute everyone if anyone wants to say anything, but I'll just answer these questions here. Okay, a cascading. Do I need to run 2 signal cables from the heat pump, or can I daisy? Great, we can daisy chain. Good question. So you can daisy chain everything that is on that bus network. Red being heat pump, so you can go to heat pump 1, jump in and out all the way to heat pump 6, and on the green bus network, the accessories, if you want, you can daisy chain all your wall controllers. So I've had that problem. It's not a problem necessarily. It's been a solution we've been provided, where we've said, someone goes, I've only got 1 cable going into the house. I go, no worries. Let's just pop off that one to the next one. Done. So, yep, it's easy. Look, if I was doing the install, if I was doing the install from scratch, would I suggest run 2 cables? Maybe. If you're running your wall controllers, maybe a bit of a fail safe on a couple of cables. I don't think it's a bad idea on some of these big installations that sort of you guys are doing. And standard install, where does the EVU wire run to? So in a standard install, the EVU wire just links into the active. So it just runs 50 millimeters across and just links into the active. That's where it goes in a standard install. So
that's just a loop.
The loop, that's exactly right. So your power comes, so you bring your power in, your bottom left, and you just loop out of your power in into the EVU.
Yep.
That's it. Do you use the elements? Do dip switches in the IWS need to be set in some specific way, or this via software settings? So no, in standard configuration running, no, they don't. So if you put that dip switch 9 up, sorry, dip switch 9, it's called dip 9 in the controller. But if you put that dip switch that I showed you up, which puts it into cascade mode, that deactivates the elements. Okay, but it will allow an external element signal to be sent still. So if you're in a single heat pump situation, the elements are designed to come on anyway. Now, so you don't have to touch any dip switches. That's the short answer. You don't have to touch any dip switches if you are doing just a standard heat pump installation.
Okay, so then a follow up on that one. Then we can use the internal heater, but only if we have 1 heat pump. Then if we had a cascade, we can't use them.
Correct.
Yep. Okay.
Correct. Internal heater. Correct. That was the. Yeah. Yeah. Correct. Correct. Okay. It's a good question. Okay, that's it. Anyone got anything? Any other questions?
Yeah, Tui, just quickly, I missed at the start, mate. He's saying the FETs are just the circulation pumps.
FETs. FETs are so the FETs are our wall controllers, internal wall controllers, and what I was probably saying in that, I'm just thinking back, was they have to be allocated for the heating circuit.
Yeah.
So because all the FETs can just get wired into the same slot on the WPM.
Yeah.
So you had, because if you put a WPM in and a WPE, we can do up to 5 heating circuits.
Yeah.
Now they just get wired into the same spot in the green bus terminal, or you can daisy chain them, as Stephen's saying. So you can just have 1 wire running into the house, and you can just loop in and out of every wall controller. So they're all just wiring back to the one spot.
Yeah.
And then when you power the thing up, you've got to say FET1, which it might be in your living section, is heating circuit number whatever.
Yeah.
So you've just got to allocate them, and we've got to make sure. And this is where it gets confusing. We've got to allocate the right FET to the right heating circuit, to the right pump, to the right mixer with the right sensor.
Yeah.
Okay. Any of those things are wrong.
Yeah.
Then you got a conflict. and that's think Torquay, Chris. This is the conflict that can exist because you've got to get all 5 of those right. Now that mightn't have been the issue. Can't remember, but that can happen. That can happen.
Will that all get done within the WPM, or does like ABC get done on the FET and then C and E get done on the WPM?
You allocate the controllers, as in the FETs. You allocate them at the controller.
Yep.
And then you can actually go onto the information on the controller and see what it's allocated to.
Yep.
But pumps and everything, you would all allocate that at you can't allocate the pumps at the WPM. You have to wire them into the right spot.
Yep.
The terminal is already allocated. So like heating circuit pump number 1 must be wired into the right spot.
Yeah.
Now, if you then, so that's what I was saying, that if you start doing a relay test, the relay test is why it's so important. You start doing a relay test and you start turning on pumps off and on. This is just all in a complete test scenario before you try and start everything. You're going in, you turn all the components off and on. You can say, all right, I'm going to turn on pump number 1. And if pump number 2 starts, you go, oh, right, okay, I've got the wires the wrong way around. Okay?
Yeah.
Good questions. All right.
Sorry, I've got a quick question too, if you've got a minute.
Yeah, of course.
Just in regards to the, on the WPM, when we're commissioning and we've set up our ISG and all that, I'm just finding there's the odd time where the WPM is the actual screen. You know how you're saying if you wire up your ISG wrong, or if you have your bus cables wired up in the wrong way or into the wrong terminals, the screen will just say show the Steeble logo on the front, or it'll do some silly things, which we've probably all seen happen a few times, and you learn from that. But I'm finding every now and then on some of the later systems I've installed is the Steeble the WPM will be working as normal. And then just out of the blue, maybe every 10 minutes, every 15 minutes, I don't know if it's 20 minutes, it's just sporadically, the screen just goes blank. And it's like the screen on the WPM is resetting itself.
Yes. Yeah.
And the system's still working as normal, no problems, operating as normal, but the WPM, like you go to touch it and I don't know whether it's coincidental, but you go to touch it and then hang on, it looks like the whole thing shuts down, but it's only just the WPM.
Yeah, I'm aware of the problem. I think we've talked about it. It isn't widespread massively, so it does seem to be a bit more unique to installations. So we're that we've got that problem at the moment, sitting just with the German text, seeing if it's a voltage issue on their bus circuit, or it's a problem with the FETs themselves. Because I have not seen, I don't know if you can expand on this, Dawson. Have you seen the FETs drop out as well?
No, I haven't seen the FET do it myself personally. No.
That's correct, and on the same. That the problem does seem to be a little bit more confined to the FES. Now remember, you can unplug that FES and that system will still run. That's why it's still running. Just if you didn't know that, because you can be there playing around and plug your FES and your pumps are all going. And in fact, if you probably had your ISG set up on it, you could probably just read it and be controlling it off the service wall.
Yeah, correct. And originally I was panicking, thinking, shit, the whole system's going to shut down. You finally get the system to a position it's working and it's it's ramped up, it's doing everything it needs to, and then the controller shuts down. But I quickly learned by going to the condenser that there's no it doesn't affect it at all. Yeah. What I
do, Dorso, if time permits and so on, does that job have FETs on it?
Yes, one FET, Grant Crescent,
And is that FET in the house, or is it just?
In the house. Yep.
And you've got say all the only accessories you've got on that job are one FET and the FES and the ISG.
Correct. Yes. Yep.
I'd just pop out the ISG and the FET and see if it does it, if that was possible.
Yep. Okay. Next time I'm there, I'll give you a buzz and I'll have a play around with it. I mean, it's not causing any issues, but I've seen probably 3 or 4 jobs now do it.
Yeah. No, you're right. We're aware of it. And the texts are all
sweet.
right.
Thanks, mate.
Good question. All right, everyone. What's the time? 12:15. Sorry. I think if there wasn't anything else, we will probably wrap it up. Is there anything else? You got anything you want to tell everyone, Rani, or you cross everything?
Yeah, no, I think it's all very good as usual. It's very good, very informative, and it's excellent, mate. And it's great to see all the features and all the things. Maybe the only thing I could say from I guess from my limited experience is that the commissioning. It's good to be able to do commissioning in stages. Even if there's no water in the system, you can do like a dry commissioning. You can set things up. You can even test the relay. I mean, you can do a relay test without any water in, because all you need to do is make sure that you just switch off the isolator at the pumps, and then you go and see, oh, there's power going there with your contactless probe, and you can even check that. So it gives us all this, gives us a fair bit of
it does. It does. The relay test, why I'm probably making such a point of it today, but the relay test is a very underused function out in the field. So realistically, people are ringing me, in a panic state, can't get anything going, yada 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 yada. Calm down. Let's just see what works, see what doesn't work. Okay, relay test everything. I've had 2 or 3, and all right, turn on the buffer charging pump doesn't go. Okay, well, that's interesting. Have you got voltage there? You got voltage there. If the plug in the back of the pump, is it pushed in correctly? No.
Okay.
Simple as that. Simple as a plug in a pump not pushed in correctly. Because there's so much componentry, because they're high end complex systems.
Sure. No, it's great. Really, it's a really good tool. I've used it pretty much all the time. Yeah. I think that's
all right, everyone. Well, once again, thanks everyone for jumping on. Hope we've all learned something. What I'll do is I'm getting back into it after lunch. I'm going to grab something to eat, and anyone that's in, we'll see you at 1 o'clock. Thank you. Thanks a lot.